So before I get into lesson 6, what I want to do is just kind of give a little bit of a background as to why it would be important or what the purpose is between entire and mixed radicals. What it comes down to is if we think back to fractions. So if I have 11 sevenths, what kind of a fraction do we call that?
Improper.
It's an improper fraction. What can I convert it into?
Mixed number.
And how would I get the mixed number, Jonathan? What would my mixed number be?
1 and 4 sevenths.
So if I then had 3 and 4 fifths, how would I take that and put that into an improper fraction? And what do I get when I go 3 times 5 plus 4? So what this means is if I have 3 and 4 fifths, it's the same as having 19 fifth-size pieces. Going back and forth between the two forms can be very useful. We went back and forth between the two forms when we had to add and subtract fractions before we depended on a calculator to do it all. If I had to subtract fractions, a lot of times I put it into an improper fraction so I didn't have to worry about that whole idea of borrowing or anything like that. And by borrowing, I mean if I had 4 and 1/7 minus 2 and let's say I went 5/7, I can't take 5/7 away from this 1, so I'd have to, in a sense, borrow. So if I change them into improper fractions, 29 sevenths and 19 sevenths, it becomes easier to subtract. Okay. So when we get into radicals, it's the same thought process. It allows us to go back and forth with our radicals, and then what it's going to allow us to do is be able to answer the question, is there ever a time where I can take a radical and I can add it to another radical to simplify it into one term? And the answer is yes. It is possible to take 2 radicals and add them together. I can't do this, but there are other radicals that I can add together, and that's what we're going to get into over the next 2 days. So, if we recall from the last lesson, the product of the roots of 2 numbers is equal to the root of the product of the 2 numbers, or the quotient, and the sum of the difference is not. So in other words, root A times root B is the same as root A times B, or root A divided by root B is the same as root A divided by B, but I can't do it for adding and subtracting. So if we look at class example number 1, write the following as a product or quotient of radicals. So if I take the square root of 24, and I write it as the square root of 4 times 6, and then I can split it up, the square root of 4 and the square root of 6. Is there anything that you can tell me about these 2 radicals? Is there anything that you can do to the square root of 4? And what do I get when I square root of k? 2. So then I have 2 times the square root of 6. If I take 18 and I rewrite it as the square root of 9 times, and then I can split it up, the square root of 9 times the square root of 2. Is there anything else I can do in this question?
3 times the square root of 2.
I can take the square root of 9. Square root of 9 becomes 3. And then I get 3 times the square root of 2, or I read it as 3 root 2. If I have the square root of 11 divided by 4, the same as the square root of 11 divided by the square root of 4. Can I simplify that? Colin, is there anything I can do with this statement? In other words, can I find the square root of 11 nicely? Can I find the square root of 4 nicely? What do I get? Okay, so now I want you to get your calculators out. And tell me what is the square root of 80 to 5 decimal places? Kirsten, what did you get? Delana, what did you get?
8.94427.
Okay. Now what I want you to do is I want you to figure out what is 2 times the square root of 20. Did you get the same thing, Taylor? Okay. 2 times the square root of 20. Okay. What about if I go 4 times the square root of 5?
The same thing.
So they are the same. I wonder why they are the same. Well, let's take a look and see. If I take 80, I can rewrite 80 as the product of 4 times 20, which I can split up as the square root of 4 times the square root of 20. The square root of 4 is one of those perfect square numbers. I can square root it to get, there's my 2 root 20. Or I can take 80 and I can write it as 16 times 5. And what is the square root of 16?
4.
And there's my 4 root 5. The square root, or root 80, is considered an entire radical. Why do you think it's called an entire radical? Because everything is entirely under the radical sign. 2 root 20 and 4 root 5 are called mixed radicals because they are a mixture of a radical and a whole number, or a rational number being multiplied on the outside. This section will eat you alive if you have trouble with your times tables. Because we have entire radicals that are sometimes pure radicals where everything is underneath the radical sign. And then we have these mixed ones. Every mixed radical, so all of the radicals in this side, can be expressed as entire radicals. But it doesn't necessarily go the other way. Not every entire radical can be expressed as a mixed. For example, the square root of 5. I cannot rewrite that as a mixed radical because there's no way of splitting 5 up to give me a nice product. Okay? So what I mean by a nice product, what do we call these numbers in this column? 1, 4, 9, 16, 25. They're perfect squares. These are nice numbers to have when I'm dealing with radicals because I can take the square root of each of these numbers. This chart becomes very important because when I'm trying to go from a mixed or from an entire radical to a mixed number, I'm looking for products that are these numbers. So if I look at 108, I want to see, can I divide 108 by one of these numbers nicely? So they've given you a hint. I can divide it by 3. What's 108 divided by 3? And the square root of 36 is 6. So the square root of 108 becomes 6 root 3. Just wait to know
We can do that. I didn't know that.
unless you get up every 3 seconds, then no.
Sorry, she's playing it.
To go from an entire radical to a mixed radical, you want to factor out a perfect square. That's what you're looking to do. Can I find a perfect square that is a factor of my entire radical? If I can, I'm going to be able to convert it. So if I take a look at the square root of 50, if I take a look at my column or my list here, can I divide 50 by one of those perfect square numbers? Can I divide it by 4 nicely? 50 divided by 4, does that give me a nice number? No. 50 divided by 9? Divided by 16?
25.
Divided by 25, it works. 25 times what?
2.
Okay. If you want to do this step where you split it up, you can. What's the square root of 25? What I want to see is that and that. If you don't show me the in-between step, I'm not going to take marks off. If you go from here to here without showing me the in-between step, I will take a mark off. $45. Can I take 45 and divide it by one of my perfect square numbers?
9.
The other hint I'll give you, put the perfect square number first. What's the square root of 9? There's my answer, 3 root 5. 320. What can I divide 320 by? Is 5 a perfect square though? I want to pick a perfect square number. 10's not a perfect square either. Look at that column right here.
Oh, I'm looking at the other side.
Look at this side.
64.
64? 64 times what?
5.
Is that the first number that you picked, Brianne?
No.
What did you pick first?
I don't know. Like, I was looking.
I'm going to do both of them. Because I could do 16 and 20. So let's look at the 64 and the 5. What's the square root of 64?
8.
8. What's the square root of 16?
4.
So I get 4 root 20. I can go from 4 root 20 to this form. What I need to do is I need to look at the 20 now. Can I divide 20 by one of the numbers in this list?
4.
I can divide it by 4. So then I get 4 times 5. The square root of 4 is?
2.
So now I have 4 times 2 root 5. And there's my 8 root 5. So if I can pick the biggest perfect square possible, I'm going to do it in one step. If I don't, I just need to recognize that that number left under the radical sign, does it still contain a perfect square as a factor? If it does, repeat the process. So I should be looking at these numbers to make sure that I can't